Okay, so they don't really give you a word problem here, but this is essentially an angle of elevation, angle of depression situation, and specifically an angle of depression. If you were looking out from horizontal here, and then you wanted to look down here to see this point, you would have an angle of depression because it's dropping. So what is that angle of depression? That is 40 degrees. Now, how does that help you if it's not inside the triangle? Well, we know that because that dotted horizontal line is parallel with this line down here, okay? That's essentially what this whole thing is about, these angle of elevation, angle of depression problems. Then you know that this is also 40 degrees because they are alternate interior angles between two parallel lines and on either side of a transversal line, which is that line that they're measuring as x. Okay, so now we've got this typical problem. And by the way, I could even go in so far if I wanted to say, okay, now I'm going to just erase the information I don't want anymore. And you can see how that just becomes a regular triangle problem to solve a trig problem. Okay, and how are you going to solve it? You're going to solve it by saying we're at the 40-degree angle, opposite and hypotenuse means sine. Sine of 40 degrees equals the opposite side, 500, over the hypotenuse, x. And we've got a trick for how to isolate x when it's in the bottom, which is to switch the position of these two. So what do we get as a result? We get x equals 500 divided by the sine of 40, or x is approximately equal to, and we're going to calculate this out, 500 divided by sine of 40. And I get 777.86, or 777.9, rounded to the nearest tenth. That's A. Cool. Let's do another. Okay. Another angle of depression. This angle here is 25. There. So by alternate interior angles theorem, that angle is 25 as well. And I'm not going to erase it this time. I just wanted to do it last time to show you that those extra pieces that are outside of the triangle are not really relevant to us anymore. We just needed this. So what do we got? What are we dealing with? Well, compared to this 25-degree angle, we've got an opposite side and an adjacent side. Opposite and adjacent is tangent. So we say tangent of 25 degrees is equal to the opposite side, x, over the adjacent side, 11. And then what do we need to do here? Well, what we need to do is multiply both sides by 11. And what it'll do is cancel out there, giving you just x is equal to 11 times tangent of 25. And that's something that we can type into our calculator. 11 tan 25, close parentheses. 5.129, it's saying round to the nearest tenth, so 5.129 is 5.1. And the units is yards, so x is approximately equal to 5.1 yards, which is D. One more. Let's do one more. Okay, first, many thanks to Maria Jose for catching my error on this. This is a good example of if you're not reading closely or you're just not really paying attention to what you're finding, you can end up choosing the wrong answer. So I'll talk you through this and I'll show you what I mean. Okay. To approach the runway, a pilot of a small plane must begin a 10-degree descent. This 10-degree descent right here, they call it an angle of depression because from horizontal, you are taking that 10-degree angle down below the horizontal. Okay, so the pilot must begin a 10-degree descent starting from the height of 1,983 feet, and that's this side of the triangle here, above the ground. To the nearest tenth of a mile, how many miles from the runway is the airplane at the start of this approach? Well, if the airplane's up here at the start of the approach, then this distance here along the hypotenuse, x, is the length that we're looking for. Okay, so the first thing that we need to know and understand is that when we have an angle of elevation or angle of depression problem, we may not have the angle inside the triangle. If you look at this 10 degrees, that's not one of the triangle's angles, but we know through alternate interior angles, if these two lines are parallel, and they are because we're always talking about from the horizontal, those are parallel, and then therefore this is also going to be a 10-degree angle. And then we just have that 10-degree angle, and which two sides do we have in relation to it? We have the opposite side and the hypotenuse. Opposite and hypotenuse is sine, so we can say the sine of 10 degrees equals 1,983 over x. And since what we're solving for is in the denominator, we have this trick where we can switch these values and come up with a new equal problem of x is equal to 1,983 divided by the sine of 10 degrees. Okay? And then when we solve this, we get x is approximately equal to 11,419.64 approximately, right? And of course, that would lead you possibly to believe that the answer is C. And that was my mistake. I was moving quickly, I wasn't paying attention to what I was doing. So why is C wrong? Well, when we look at this problem, we can see over here that the units that are given, that we used 1,983, what are those units? Those units are feet. So what we actually have found is the number of feet that the plane is from the runway at the start of the approach. So this answer, C, is in miles. It's saying that you're more than 11,000 miles away. And you're not more than 11,000 miles away. That would be far too far away. That's like, almost halfway around the world. That doesn't make any sense. Okay, what we need to do is we need to convert this number of feet, into miles. And how do we do that? We take this number and we divide it into groups of 5,280. Every group of 5,280, because that's how many feet are in a mile, every group of 5,280 feet we make is going to be 1 mile. And so therefore, when we divide, and let me just check my math here, we get 2.16281 approximately. And let me put approximately 2.16281. We don't need all those digits. What do we need? We need, well, we're rounding to the tenths place. We need to examine the hundredths place and say, does that number basically mean we've got more than half of another tenth? And since it's 5 or higher, that means we do have more than half of another tenth. So we call that just another tenth and go from 2.1 to 2.2. And now we have our information in miles, which is what they asked. If you look up on top, how many miles? It says, how many miles to the nearest tenth of a mile? Okay, and since we have that, we now have an answer of 2.2. Notice that they also gave us 2.1. If you round it incorrectly, you're going to choose 2.1. But it's actually 2.2 when you round it correctly. And the answer is A. Thank you, Maria, for helping me correct this. Much appreciated.